Hi everyone, I hope you're okay, and I really hope that guys the videos will keep uploading and helping you out. Please guys, don't forget to subscribe if you are new to the channel, and don't forget to like the video. Please share as much as you can, just to help us to grow the channel, guys, so that we can reach other learners as well. uh on this video, guys, I'll be just tackling question one from the May June examination. It's the IEP examination. It was written in the year 2024. Please note that each question will have its own video. So since this question have 12 questions, that means I'll upload 12 different videos. Just stay tuned, guys, and wait for more. Okay, let's start. We are supposed to solve x here. Now, I have two things multiplied and the answer is 0, which simply means that the first thing is 0. I have 3x minus 4 is 0, or the second thing could be 0 as well. So all I need to do here is to just solve for x. For this one, it's just simple. I'll just take the 4 to the other side. It will change the sign and then divide both sides by 3. I will have 4 over 3 as my answer. And then on the other side, I just need to factorize this one. Yeah? I want to have the factors of 9 that when I add will give me 6. Those factors are 3 and 3. Since the sign here it's positive, it simply means that my brackets will have the same sign, but not just any sign, the sign of the middle term. So I'll have plus here and a plus there, and then x is equal to negative 3, or so these are the only solutions. I don't need to write the same answer twice. The solutions are x is 4 over 3, or x is equal to negative 3. Okay. Second one, I'm supposed to solve x, right? I'm given a square root equaling to a negative number. Please note that, guys, for this equation to be real, right, there's no value of x that I will put here and give me a negative number. Everything under a square root is always greater or equal to 0. If you can check here, I have the square root of a is equal to b. The value of b will be always greater or equal to 0, because there's no value of a that I can insert inside the square root and give me a negative value. So in this situation, I'll simply say there's no solution. There's no solution. Okay, now let's move on. We must solve logarithms. For me to remove logs, I simply have to be left with 5 here, and x will be on the other side. 3 will be the exponent of x. I'm supposed to solve x, which means I must isolate x, right? Then I must just insert the cube root both sides. Therefore, x is equal to the cube root of 5. Okay, I'm solving x now, and x is at the exponent. Please note that, guys, whenever you're solving x and x is at the exponent, the first thing you need to do is to separate your exponents. After doing that, just factorize, and then everything will fall into place. Okay, before I even separate my exponents, I can write the 4 to the x as, no, let me rather change that one. This is 4 to the x, right? Remember that I'm supposed to separate the exponents. Why am I separating exponents? Because my terms are separated by a plus or a minus. Right, together. So since I have 4 to the x, I'll simply say 4 to the x multiplied by 4. This is the same as 4 to the x. Why? Because 2 squared is equal to 4, right? Let me just write it like this. 4 to the x is 40. Why am I saying 2 to the x squared is 4? because this guy 2 to the power 2x can be written like this. Are you together? Why? Because powers and exponent, they multiply one another, and whenever I do so, I'll still get this one. Are you together? And then this is the same as 4 to the power x. So when I see this guy, I can simply write 4 to the power x, right? Okay, and then all I need to do now is I can use a k method, or I can easily take out a common factor. Whenever I take out a common factor, I can say 4 to the power x is equal to 4. Okay, 4 to the power x, then I have 5 here, 40. When I divide both sides by 5, I have 4 to the power x is equal to 8. I'm solving x. I'm solving x, and I'm supposed to make bases to be the same and then drop the exponents. So 4 to the power x, remember that it can be written as 2 to the power 2x, right? So I'll simply say 2 to the power 2x is equal to 2 cubed. 8 is 2 to the power 3, right? Now when the bases are the same, I can simply say the exponents are equal. Therefore x is equal to 3 over 2. Another way I could have done this, I could have changed 4 to the power x, right? After this step, let me write in blue. I should have said I have 2 squared all raised to the power x plus 1 multiplied by 2 to the power x is equal to 40. This will give me 2 to the power 2x plus 2. I have plus 2 to the power 2x is equal to 40, right? And then now I have the same base on the left hand side, right? All I need to do is to separate my exponents. I will have 2 to the power 2x multiplied by 2 squared plus 2 to the power 2x is equal to 40. I can simply say let 2 to the power 2x to be equal to k. This simply means whenever I come across 2 to the power 2x, I'll just substitute a k. So I have 2 squared multiplied by 2 to the power 2x. 2 squared, remember, that is equal to 4. 2 to the power 2x, I said it's k. And then I have k again is equal to 40. 5k is 40. Then k, divide both sides by 5. 40 divided by 5 will give me 8. Remember that I'm not solving for k, right? K was just a tool to help me to get to the solution much more easier. So whenever I see k, I'll simply substitute 2 to the power 2x. I'll have 2 to the power 2x is equal to 8, which is 2 to the power 2x is equal to 2 cubed. 2x is 3, then x is 3 over 2. Just like that. All right, together. Okay, and then now let's move to alphabet E. I'm supposed to solve x and I have fractions, right? For me to solve x, there are steps I need to go through. I need to remove fractions, sets, or brackets. In this case, I have fractions. The first thing I need to do is to remove them. How can I remove them? I must multiply both sides by the LCD, right? And since I have only one denominator, so my LCD is simply x minus 2. So remember that, guys, whenever I have a fraction, I must have a restriction for my answer, right? The restriction should say x minus 2 should not be equal to 0, which simply means that x cannot be equal to 2. Whatever x value I find, it cannot be equal to positive 2. Why is that? Because whenever I substitute x back to the original equation, my denominator will be 0, and I don't want to have a denominator of 0 in maths because that will give me undefined. Okay, whenever I multiply both sides by the LCD, I'll simply have 8 minus 4x is equal to x multiplied by by x minus 2, right? So 8 minus 4x is equal to x squared minus 2x. Now I don't have brackets, I don't have sets, I don't have fractions. I can simply solve, right? The next step I need to do is to put everything to be in standard form. So I'll have x squared minus 2x plus 4x plus 4x minus 8. This is equal to 0. The ones that are written in black, please note that I've moved them from one side of the equation to the other, and hence they change their signs. So I simply have x squared minus 2x minus 8 is equal to 0. I want to have the factors of 8 that when I subtract will give me 2. That's simply 4 and 2. There's a plus there, skis. Minus 2 plus 4x is positive 2x, right? Okay, since the constant term is negative, it simply means that my brackets will have different signs. The bigger factor will always take the sign of the middle term. So the bigger factor is 4. That means 4 will take the sign of the middle term. Then I'll have a 2 there. So in this equation, I simply have x is equal to a negative 4 or x is equal to a positive 2. But please remember that this one is not applicable. This one is not applicable, right? So therefore, x is equal to negative 4 only. This is the only solution. Okay. F, I'm told to consider the equation, and I'm supposed to solve x in terms of k. I have the equation as x plus k all squared is equal to 2k plus 1. I have brackets. I can remove the brackets, right? By doing what? By inserting the square root on both sides. But please remember that whenever I insert a square root on both sides, on the right hand side, I need to say plus or minus. Are we together? So this thing simply means that I'll have x plus k is equal to 2k, is equal to plus or minus the square root of 2k plus 1. Whenever I'm solving x, I'm supposed to isolate x, which simply means I should have x on one side and everything else on the other side. So now I'll have x is equal to negative k plus minus 2k plus 1. This is my solution. I have solved x in terms of k. Okay, the final question says, hence or otherwise write down two positive values of k for which the roots are rational and real. If the roots are rational, guys, it simply means that everything that is under a square root should be a perfect square. Are we together? I should have a perfect square there. So what are the values of k that will give me a perfect square? I just need to do trial and error. I'll simply substitute. Let me try and open the calculator for you to see. Yo, this thing has erased everything. But I really hope that, guys, you were writing down. If you weren't writing down, please go back to the video. Just rewind the video. Remember that I had x is equal to negative k plus or minus 2k plus 1, right? For me to have an answer which is rational and real, it simply means that my delta or anything under the square root has to be greater or equal to 0. No, not greater or equal to 0 rather, but it has to be a perfect square. Are you together? So how can I find a perfect square? I'll simply say 2 multiply, and then I have a 1 there. All I need to do is to just keep on substituting different values that will give me a perfect square. Whenever I substitute 1, I'll get 3 as my answer, and 3 is not a perfect square, right? So whenever I substitute 2, I get 5, 3 gives me 7, 4 gives me 9. So k can be equal to 4, and 4 will give me a perfect square, right? They said they want how many answers? Two positive values. This is the first one. 5, 6, 7, 8, 9, 10, 11, 12. Another value of k is 12. So I know that when k is 4, I'll simply have real and rational roots. Remember that, guys, according to the nature of roots, if your roots are real and rational, it simply means that delta is greater or equal to 0, and your delta should be a perfect square. The criteria of having rational roots. I hope guys the video was helpful. Excuse me that it erased the work we've done, but I really hope that you paused and went back to verify your answers. Just stay tuned and wait for more videos, guys. Thank you.